Can we all
We
hear
can hear
me?
you, sir.
Oh, all right, all right. So we'll be talking about preprocessor and structure in C. Okay. So before I dive in, we have to understand what preprocessor is, and again, you have to understand, why do we need to learn preprocessor? Okay. If you have been following my classes, I have to say that you have to understand the reason why you want to know a concept. Like, does it worth it? Does, like, what you want to learn right now, the new concept you want to learn, does it worth it? Is it compulsory for you to learn it? So now, what is preprocessor? So preprocessor is C programming. Okay, let me just put it this way. Preprocessor is a component of a C programming language that perform, processing task before the actual compilation of the code begins. That is a component in C programming that that preprocess task before the actual compilation, of the code begins. Please, can you mute yourself? I'm recording this class so that we won't be having, noise on the ground. Like, okay, so now, for example, when let me just put it in a word. Let me change my color to this color. All right. Yeah. So simple definition: preprocessor, you know, um, is a comp like let me start with is a component in C programming. Okay, that that perform preprocessing preprocessing you know that perform processing task, yes, before the actual compilation. Okay, before the actual compilation. Okay, now preprocessor is a component in C programming that perform preprocessing tasks before the actual compilation. That is, in C, the way C is structured, we have to compile C, your code before you can, run it, right? Now, preprocessor is a component in C that, for before your program is being compiled, before your program is compiled into object code, it has to go through some phase, like through a step. Okay, it has to go through steps to what before it will compiled. So I will love to show us like the in C programming, everything, though the whole thing starts from your source code. Your source code is the first thing in C. Like, even any programming language, your source code is the first thing, before the second stage, right? Now in C, your first thing is to write a source code, a code, a program. Then after you are done with writing a program, then the next thing, before your program can run, before you can see the beautiful things your program wants to do, you have to what? It has to pass through some steps, some stages before it can run. Okay, it has to pass through some stages. Now the first stage your code will go through is the preprocessor stage. Like, when we say preprocessor, when we say preprocessing, like, the compiler will preprocess your code, we scan through your code, before your code will now go into compilation, before your code will be compiled. So your compiler have to check through the code, scan through it. Is it okay? Do you have a good formatting? Do you have a good index? Do you have a good end of line? All those stuff like that. Okay, before your code will now enter into compilation stage. Okay, now this is how it goes. See this P as preprocessor. Then the next thing it is moved down to I'm trying to show us how it is being, how it is done. The first stage is the first stage is that you write your code. The next thing, when you run GCC, GCC your code, your file, then the first stage is the preprocessor stage. Then after that, it will now move into compilation stage. Okay, compilation stage. So I will use the sorry. Let me just okay, sorry, let me just remove this. Let me just use oh no sorry guys. Okay, yeah, let me just use an arrow here. Okay, so my P is the preprocessor, right? Then the next thing is compilation. So I will represent compilation with capital letter C. Okay, now after your code, after the compiler has scanned through your code, check if it's okay, everything is all right, then it will now enter into compilation stage. Okay, it's now enter into compilation stage. Then after that, it's now enter into assembly. Okay, assembly stage. I will represent with A. Then after that, it now enter into linking. So linking is the end stage. So the first stage is the P, second stage is C, third stage is A, and fourth stage is what? Is L. That is preprocessor, compilation, assembly, and linking. Okay, now this one here, this preprocessor, as I said earlier, it will preprocess your task before the actual compilation. That is, it will go through your code, check, scan through your code, check if your code is okay, it's all right. Then after that stage, it now enter into compilation stage. Now compilation stage will just compile your program and compile it into assembly. This assembly is just like assembly code. Assembly deal with object code. Okay, object code, right? Now see we this compilation will compile your code into an object code. That's why we have what's it called, in our during our tasks in ALX, we talk about, we have done a task on library that we compiled from our .c to .o, right? And from our .c file, we now compile it into object code. So that's how that's the process. That is from the words after processing your code, your program, your file, the next thing to compile. After the compilation, it will now compile it into object code. Because the reason why it's going through this through these stages is because system does not understand this any higher level languages. Okay, they don't understand, if, they don't understand they don't understand array, all those stuff like that. It only understand O's and one, which is binary. That's why we have to compile our code into object code, and that's why this has to go through this process. That's why we have our P down to C down to assembly. Assembly is like is the object code. Then sorry. Then after that, we now what, link it. Then we now have the linking stage that will link everything together to give us, after the object code, then it enters into linking phase. Then after that, it will now what, output what we expected, what we like. It will output the instruction we gave, or we wrote into our in our code, on our program. Please, do you understand the introduction? Can I move on? Do you all understand? Hello?
Yes, sir.
Okay, awesome. Okay, so now why do we need to learn preprocessor? Why do we need it? So now, why do we need to learn preprocessor? Why? Why is it compulsory? Why do we need to learn it? Okay, the reason why is because is the reason is the explanation I gave now. That is, we need it because our program has to go through some process, through a process. Our program has to be processed. Our program has to be scanned. And also, the reason why we need preprocessor is what's it called? Because let me just, I'm coming, give me a moment. Let me go through I jot something down here. Okay, so number one reason here is macro expansion. Macro expansion. Macro is deduced from preprocessor. Okay, is what deduced from preprocessor. Okay, so macros and preprocessor are what? Same thing. Macro is inside preprocessor. So without a preprocessor, there's no macro. Okay, so that's why macro expansion, we have file inclusion. The reason why we need to learn preprocessor is because whenever we want to run our program, we have to include a header file. Okay, we have to include header file, right? We have to include our what's it called? Our library. We have to include functions, right? All those stuff like that. So, and without those, I mean, if there's no preprocessor, we cannot, have those. We cannot include our library. Then our program will be useless. Okay, and also, we have conditional compilation. I will show us that in a moment. And we have, compiler specific directives, as I said earlier. Directives. All these, include, all these, what's it called? Include. So all these are what's it called? All these include stdio.h. Okay, all this stuff like that. All this now, this one now here now include stdio.h. Now this is a directives. Okay, this is a directive. Have you been wondering that now in ALX you have to create, what was it called, a header file? You have to include it in our program, right? Now, why are we not using this this greater than and less than, this tag? Why are we not using them? Now it's because this tag here shows that this stdio.h is a directory. That is, I am pointing to a directory. I want to access my function from a directory or my library in a directory. C language, what's it called, our stdio.h, all those library like that, they are what? Dynamic library. They're all dynamic because we are what? We are sourcing them, we are loading them, from a directory. Okay, now this include stdio.h is a path to what? To where you store anything that is like anything that appertain to standard input and output. Shey you get? If I include this now, include stdlib.h, okay, yeah, I am what? I am including the directory where my library is located, where my library is stored. That the directory is always on your system, is always at I think /var/user/lib. Okay, that's where library is stored. So I am loading my, what was it called, my stdlib.h from that library. Shey you get? So this tag here, they means that it is a directory leading to leading to a directory. Now when I have something like this, include main.h, this one is saying that in my present directory, where I am in my present directory, that I can what? That's why I'm using this I'm using string literal. I'm using double quotes. That is, in my present directory, that's where my file, my function, prototypes, all those stuff is kept. Are we getting it? Hello? Am I communicating?
Yes, sir.
Yes, sure.
All right. Now, again, preprocessor always starts with hash symbol. Okay, that's why we used to have hash here, hash here, hash here. Okay, that we always starts, what's it called? Your that starts your hash symbol, yeah, just like always starts your inclusion. Okay, if that hashtag is not there, then this hashtag, if it's not there, then this is just a normal writing, a normal normal thing, you like, a normal word. Shey you get? But that hashtag shows that this is a a directory point. This include means that include this directory, okay, to my file, so that I can load my, what was it called, from that directory. Do you get that? Okay, so real quick, I have explained file inclusion. I have explained compiler specific directives, right? Now I want to explain macro expansion and conditional compilation. Okay, macro expansion and conditional explanation. So I will start with macro expansion. So let's start with macro expansion. I'll change this one to black. Macro expansion. Okay. So let me change back mine. Okay, macro expansion. Now, macro expansion, as the name sound, expansion. Now, if I have, I said that our preprocessor starts with hashtag. Now we start with what? This hash like this. Now, and I said include, or let me start this way. Please give me a second, guys. Now, macro expansion is expanding your variable, or substituting your variable all through your program. That is, macro expansion have, I start with hash define. Okay, it starts with what? Define. That is, I want to say these macro expansions, it look like a global variable. Okay, a global variable that I want to use all through my code. Okay, now define, what's it called? Define, let's say max. And again, macro expansion, if you want to declare macro expansion, you have to start with all in capital. Okay, all in capital letter. And macro expansion does not have like end program. That is like this 20 and I put this. It is wrong. Okay, because the reason why it is wrong is because, now before I explain that, define max 20. Now this 20 here, I'm saying that I want to use this max, okay, in my program, all through my program. So this max here is just like what? A global variable. Okay, a global variable. All right, now when I enter into my program, here now is what? I defined a macro expansion of max to be 20. Okay, then I say int main, like this. It is not doing anything. Okay, if you have been following me, like since yesterday, I said that our main function is an entry point to our program execution. Now I have something like this. Let's say I have that I want to do something. I can just say that max. I can say max, okay, equals to let's say max. I'm calling my max plus 2. Okay, then I want to print out my max. Okay, then I want to print out my max. Print f, percent d, percent new line, then my max. Right here now, macro expansion. Right now, this max 20. Now when I say define max 20, I'm saying that whenever I call this max, this max, okay, compiler will now interpret this max, and wherever I see max, we now substitute max with 20. That is, this whole thing will be expand to 20. So if I now have something like this at the end of it, so I'm saying that my max, that will be 20, then this end of program plus 2, which is very, very wrong. Our this exclamation, semicolon, right, means end of a program or end of a program. Yes. Okay, now when I put 20 semicolon, it means that I'm only having these 20s existing, but this plus 2, I don't know about it. So that's why we don't use the word include this. Okay, so in other words, we now have something like this. Okay, we now have 20 plus 2. Okay, so now this one has been expanded to 20. So anything I put here, so in other words, I can use these marks in any, like, all through my program. I can use these marks. Okay, so that's how we call macro expansion. So we now have two types of macro expansion. We have object like macro expansion, and we have function like macro expansion. Let me quickly do that now. We have object like, macros, and we have.
Please, can I ask a question, sir?
I
have a question, sir.
Okay, I'm coming real quick.
Okay.
Now ask a question.
Okay, sir. Please, I'm yet to fully understand the macro expansion, that the introduction. Please, can you, if you don't mind, like what do you mean by the macros? Because I don't want to assume that I know it. Then can you just explain like the macro and? Can you hear me now?
I can hear you now.
Okay. No, I was just saying, can you please maybe like take it again? Like can you explain what macros means, and then the expansion, like the two terms, and link them together, then before we can move to the types, please. Thank you.
Okay.
I'm here to fully understand.
Mark as your question. Macro expansion. When we said macro, the word macro means oh God, macro, right? Now, macro expansion, yes, it means when is a process when you expand this. Macro expansion is a process when I substitute my definition. God, how can I explain this? Okay, macro expansion is a process of replacing, just note that keyword, of replacing macro invocations. Now, this one here, okay, let me go ahead. Macro invocations with their corresponding macro definition. When I said replace, I think you mark the word replacing, and again mark the word corresponding, and mark the word invocation.
Okay.
So we mark the word replacing, then the word corresponding, right? And the word invocation. Now, I'll take it again. Macro is the process.
No. Help us see if I can define it for the guy so I can understand it more well for the macro definition.
Okay, just give me a moment. I'm coming.
Okay.
Macro is a process of, number one, replacing. Okay? Of replacing macro invocation. Okay? This is the invocation. Then number three, with a corresponding macro definition. That is, here, when I define max 20, yeah, this is a definition of this max 20. Okay, so when I now call these max here, it means I am invocating the max. Okay, then these max will now be replaced with this 20 here. Same thing as your variable, that it will replace this marks. You know, this marks is a word that I use here. I call this variable here. Okay, so this variable will now be replaced with the number, with the value I initialize it to. And this marks now will now be 20. That is the marks that is I replace this max with this 20 in my program. That what we call is a process of replacing macro invocation. I invoke it, then with the corresponding macro definition. I don't know if you get it.
As a token. So instead of if you want to perform a particular task, partaking to that macro in your program, instead of you writing the function again and writing the stuff again, writing the code again, you just call the macro, since you included it in the
Okay.
And again,
thank you.
In addition to what they said, just see macro as your normal variable. Okay, your normal variable. When we have int a equals to 5, right? Now, if I want to print out this a,
sir.
what will I print out? Is it a or 5? Now, if I want to print out this a now, what will be the output? Is it a or 5?
If you print a, the output will be 5.
It is what?
5.
It will be 5.
5, exactly. That's macro. Shall you get? Now, if I define my macro here too, okay, I said define macro, let's say max, okay, or m equals to 20, okay, or equals to 5. If I print out this m, 5 will be outputted for me. So this 5 will output on the what? On the cursor, on the console for me. Do you get what I'm saying?
Yes.
So the way your integer, and again, see this is true. This macro is always an integer. Okay, macro is always an integer. Always an integer. Shall you get? So
yes, sir.
Are you with me?
Yes, sir. Can hear you.
So in other words, the way you will print your variable, the way you will use your variable is the way you will use your macro. This m here is a variable, this a is a variable, but the difference is the what? The definition or the declaration. Right? The way I define this m, the way I define this variable is different to the way I define this a. Do you get this now?
Yes, sir.
Awesome. Okay, so I said we have objects like macro, right? Objects like macro, and we have what's the next thing? We have function like. Okay, function like macro. Now, what is object like macro? Now, this is an example of object like macro. That is your macro that you define without, it's not expecting any arguments. Now, this m here is a variable holding this 5. Okay, so now if I want to print out this m will be, when I print out m, 5 will be output to the what? To the console, right? So now this is an example of object like macro. Though we have some cases too that for instance I can have something like this. Okay, I can have something like this for object macro, that hash define let's say sum, okay, or let's say pi. Okay, now I can have something like this. Pi, you know our pi is 3.14, and let's say I want to plug it with something. Okay, I can do the arithmetic here direct. Shall you get? So now with this is an object, you know, object like macro, because they are not, you know, they are not, you know, they are not accepting or accepting any arguments. We are not passing any argument to them. They're just your normal variable that you plug together, or your normal variable that you want to do an arithmetic on. Okay, that's what we call object like macro. Okay, and they always start with what? Hashtag, hash, you know, hash, then define. Okay, now even you can have something like this in object like macro. You can have something like this too. Have something like this too. Hash, define, you know, define x. Let's say sum. Okay, then I want to have x. Okay, now that says this sum is what want to like this sum here will be like I will passing a, now this one have a parameter. This is I will passing an argument to this, but still it is not a function like, it is still it is still an object like macro. Okay, but now obviously I want to have, you know, with this extra I want to have x plus x. Okay, so you know, x plus x, then to give me what? My answer, my, you know, we said sum, right? X plus x. Shall we get? Now this x plus x here, you know, the way we you know, we declared, we define it here is still a you know, an object like macro. Okay, but once you have something like this, sum, then I'm passing x. Okay, I'm passing something like this, then this is what? Function like macro. Okay, this is function like macro. Function like macro is, if you are in today's this morning lecture, I mean meeting, you understand that, I mean you understand this thing very quick. You know, this morning I said that our function is a variable, right? But what differentiates function from variable is the what? Parenthesis. Is the parenthesis. Now look at here too. We have this closing and this open and close brackets, braces, brackets. Shall we get? So in other words, this is a function. A function. You know a function now. But if I write int add, this int add like this is a variable. But once I input this parenthesis, it shows that this is a function. Same as this too. Okay, because I have this open then close, and I have this x and x. That shows that this sum, this macro is a function like macro. But this one now does not have any parentheses that I can just, you know, write it and, you know, perform anything with it without having these parentheses. Then it is called object like macro. Do we get that? Do we get that? Hello? Do we get it? Yes. Okay. So let me quickly do a demo on object like and function like macro, so we can understand it more better. Okay. I should go back, or like I should re-explain the function like macro, right? Hello?
Yeah, I mean the function.
Now, you start with define, right? Now I said function. What's make a function? What's make a function is the parenthesis. Okay? What make a function is the parenthesis. Or the norms. If I input int words, I will use again int add. This add is a variable. It is a variable. But once this parenthesis comes in, it now will turn into function. Then compiler will now see it as a function. Okay? Because this parenthesis as what come in. Now, same thing as function like macro. When I said include, and I said define sum. Okay? Then my sum is expecting one argument, x. Okay? Then I have to what? Pass in the argument. I have to, now I said x, right? And I declare this to be sum. In other words, on a norms, like even with a layman, be like, okay, sum. You are trying to plus two things together. So definitely I have to continue this definition. Okay? So when I now input something like this, I open and close parentheses. Now, enter that parentheses and now what? Input the x. I will explain the reason why I'm using this on the norms. I can have it like this: x plus x. Okay, x plus x. This word is a function like macro. But the reason why I'm putting another parenthesis here, it is because of the precedence. I will talk about that before the end of this class. Okay, now with this, I have this open and close parenthesis, and inside it and I have my x plus x. It now shows that my this macro is a function like macro, because of this parenthesis, not because of this one. Okay, because of this outside one, this open and close parenthesis. That's what make it a function like macro. Do you get that now?
Yeah.
Awesome.
Yes.
So let's do a demo. Now let's now see the work of like how to use function like and object like. Agba or Grim, I see it. Sorry, I don't know if I'm pronouncing your name very well. Let's define. Now you start with the keyword define. Okay. Now let's see. Can I hear that sound, please? Now 10. Now this int max here and this define max here, they are the same thing, variable. But the difference is that this one is a macro because of this keyword define. But here is what? Integer data type. Now when I say that int max equals to max, so I'm basically saying that now this max here, as the from the definition, replacing, that is, now this max here will be replaced by this value 10. Okay, by this value 10. Okay, they will now print out this max, then this max will output 10. Let's check that. gcc example3.c. Can we see now? we have 10. That's confirmed that our marks is a variable, and our marks is what is replaced by this 10, by this value. Okay, and this is an example of objects like macro. Objects like macro. Then I can now perform arithmetic on it. I can say marks plus 20. That is, I want these marks. Now you know these marks automatically will be what? Replaced by 10. They will now be marks equals to 10 plus 20. Now let's check it out. Then we should have 30. Okay. That's and again, let's do something like this again. Marks, you know, I talk about object like macro that you can have something like this, some x. You can say x or some or x plus x, right? X plus x. Then by passing my sum here, definitely my sum will take what? We take two numbers, right? No, just one. I mean, now passing 2. Okay, I'm passing 2. Now automatically this one will what? Output 4 for me. Output 4. Let's check it out. 4. Now this is an example of object like macro. Object like macro. That is, this thing is expanded and replace my x with what? With this value, with this, you know, this addition, and I pass in the value, then it print out my 4. Okay, but it be like, okay, like it be like, what's going on here? Then I have parentheses here, and I have x plus x, and I'm still calling it an object like macro. And in my explanation, I said whenever you see a parenthesis in any variable, that means that variable is a function, right? Now this one here, x, this one here, and I have what? Parenthesis here. Now this is not a function like, because now this x here, all right, you know, on the norms I have to have like maybe a one word, one value, you know, but in what's it called, in objects like in macro generally, okay, I can pass in a value to my object like. That's why I have this parenthesis of x. Then now what can now differentiate object like to function like is the second parenthesis. Okay, the second parenthesis. This first parenthesis is just a normal thing for macro, but once you have second parenthesis, then it shows that this is a function like macro. Okay, but if I now have, you know, x plus x, okay, now this is a function like macro. It will give me the same answer, 4. And this is a what? Function, you know, function like macro. Now this program is working fine, but there will be but there's an issue when it comes to precedence. There will be an issue when it comes to precedence. What is precedence? I think, do we all know what precedence means? Hello, do we all know what precedence means? Hello?
No.
Okay. So precedence is just the way our arithmetic, our symbols will work. You know, the way that is, if I have plus, I have minus, I have this plus, minus, multiplication, division, modulo. Once we work, if I have this thing here inside a program in one line, which one of these will come first? Which one of these will run first? That we call precedence. The one that have precedence means that the one that have higher that have higher range, or that have higher number than the other, or that is greater than the other. Okay, so in other words, if plus is greater than this minus, then plus will execute first before minus. If minus is greater than plus, this minus will execute first before plus. And same goes as this the rest too. That's what we call precedence. Okay, this is the first thing. I mean, this is the first thing that like a programmer should know. Like, you know, you want to learn programming, you should know the precedence and the associative. I think I will pick a day for that to explain, because that one alone can take a whole hour or 2 hours, because it's somehow, you know, crazy. But I will just explain something here. Maybe some other day I can just choose a day for that. Shall we get? Now, in the like, how do I, okay, now precedence of plus, minus, multiplication, division, modulo, and these assignments. Okay, these assignments. How can I explain this? Okay. I don't want to you know, take us too high. Let me just stay here on this. Now, the precedence of anytime you see, or let me start with this, plus. Okay, anytime you see plus, minus. Okay, plus, minus, this multiplication and division, modulo. Now this one has higher precedence than this one. That is, multiplication, division, modulo, they have higher, they are greater in height. Let's put it that way, in height. They are like egbon, they are like the oga. That is, before you can reach minus and plus, you must reach this first. So in other words, if this and this are like on the same line, all this one will execute first before this minus and plus. Before this minus and plus. I will show us in a code now. You know, here we have x plus x, right? Now let's now do something real quick. Let's have something like this. 4 plus 5 divided by 3 over by 3 times this, right? Or like this. Let's put it this way. Sum, that is, let's pass in our 2 plus 4 times 3 divided by 2. Look at this. We have, you know, this plus this one plus 4 times 3 divided by 2. What will be the answer? You know, the first thing will be like, okay, here now, our x plus x, right, This one should give us what? 2 plus 2 should give us 4. Now, the next thing should be 4 plus 4. Then the next will be 4 times 3. The next will be 3 divided by 2. Well, it is wrong. Because in the in my year, I said that the precedence is when this precedence of multiplication, division, and modulo, they are higher in precedence than plus and minus. Okay, and x is higher than this division, but this x division modulo, they are in the same group, but they are the same group, but this multiplication come first, followed by division, followed by modulo. Same thing as these two. Okay, for the addition and the subtraction. The addition, though both of them here, they are on the same group, but this plus come first, then this minus follow. So that is, whenever this program wants to execute, okay, it will have to what start from here. That is 4 times 3 first. Okay, divided by 2. Then now plus by this. Okay, then now plus by this. Now let me run this program. I'm coming. Our answer is 10. Now let's do it on mathematics. Please, what is 4 times 3? Hello, please, what is 4 times 3? Hello?
12.
12. Then let's have with this. This one is the first one, right? That come first, right? That is 2 plus 2, that is 4, right? 4 plus 4, that is 8. 8 times 3 is what? 24, right? 24 divided by 2 is what? We have 12, right? But it is giving us 10. This, am I right? Hello?
Yes, you're right.
Okay. Now, here I now have 10. What's happening? This is how this will execute. First thing, it will what? Do this one first. 4 times 3, 12. Right? 12 divided by 2. Okay? 12 divided by 2 will give us what? 6. Then 6 plus 4 will give us 10. Okay? As you can see, there's what? Higher in the precedence. Now, if you now let's try to put that. Okay, it will be like this. 4 times 3, 12 divided by 2, 6. Then this one will what? We expand to 2 plus 2. Then that is 4. That is 4 plus 6. Then have our 10. So if you are doing something like this, you have to, if you want this one and this one to execute first. If you want this one and this one to execute first, then you have to what? Cap them in a parenthesis. Parenthesis, bracket, square bracket, like parenthesis and square bracket plus increment, decrement. They have the highest precedence in any programming. They have the highest precedence. So once I camp this and this together, so I'm saying that this 4 and this one to execute first before this and this. Now let's say a scenario whereby I want to show us something about this line of code, which is wrong. Let's say we have 4 times, sum of words of 2 plus 3 divided by, let's say, 2, right? Or let's put something here, divided by, then here let's put our multiplication. Now, how will this program work? What will execute first? On the norms, will be like, okay, the way this is arranged, then that will be 4 divided by this first, then plus this times 2. Let's see what this program will output for us first. 7. What's happening? Now, first thing, 4 divided by 4 is 1. 3 times 2, 6. Right? 6 plus 1, 7. Then it has put 7. Right? Let's say though this is right, because this will execute first. 3 times 2 is 6. Then the next thing we do this one, then we now plus them together. This is right. I'm finding a scenario whereby I can I want to show something. I think I wrote a program that explains it. I'm coming. Let me see example 2. Is it here? Example 1. Okay, what I'm trying to see here is that if you want to have a good like answer, this your x and this x plus x here. Or okay, I think I can do something. Let's say we have some 2 times times 3. Maybe this one will explain what I want to explain. We have 12. Obviously, we have 12. What can I use? What can I do? What can I do? Okay, the example is not coming forth though. God. Okay, let me do something now. Let's say we have some, we passed in our 2, right? We now have let's say divided by, I don't know if this is a good example. Obviously we give us 2. Anyways, maybe if I come up with any example, I'll let us know to prove something. I want to prove something here. That is, this x plus x, you have to include them, like add a parenthesis, so that we do away with conflicts. Okay, add a parenthesis. Now this shows a function like, you see, giving my answer will still be what? 2. Okay, please, are we still with me? Okay, enough of what's it called, function like macro and object like macro. So let's now see. I say we have macro, we have macro, and we have what's it called, we have compilation preprocessor. Sorry. So I mean conditional preprocessor. Conditional preprocessor. Now, if we're talking about conditional preprocessor, it's same thing like the way we, all right. Now, compilation. Yeah, good. What do I call it now? Conditional conditional preprocessor. Okay, conditional preprocessor. Now when we say conditional preprocessor, like it's the same way we have our control flow, that if if else statement, our if this is that, do this, else, or we have our if state, we have if block, else if, and else. The same way, same thing as conditional preprocessor. Okay, so in conditional preprocessor we have define, we have undefined. Let me just name them down. We have define, and it is substitutes, like it substitutes yeah, thank you. Define, it substitutes a preprocessor directives only if the condition is true. We have undefined. Okay, that undefined, it undefines a preprocessor directives. Let me, as I am explaining, as I am putting them down, I'll be explaining them. Okay, let me just comment out this and comment out this. Okay, now I said first thing that define, it substitutes a preprocessor directives only if the condition is true, and undefined, it undefines a preprocessor directives. Before that, let me quickly talk about if, and if defined, and if not defined, and else with end if, end if. Yeah, so we have if defined, that is check if a macro is defined. If not defined, it check if a macro is not defined. Else, it is used with if def, if not defined, to specify the alternative code to be executed. Same thing as our control flow, if else. If this one is not true, else do this thing. Okay, if is same thing as else if, but in macro preprocessor is called if. It is used with if, obviously, if defined, if not defined, to specify the alternative code to be executed. And we have end if. It is used to end if defined, if not defined, conditional preprocessor directives. So your if defined, your if defined, your if not defined, your else, your if always end with end if. Okay, end if always end the if def, if not defined, else, if. Okay, now let me give us an example of what I'm saying. Now I said define. The first thing here is what? Define, right? And I said it substitutes a preprocessor directive only if the condition is true. Only if this check, if this if check, if define check, if not define check is true. Okay, now define. Let me define version 1. Okay, then I can now come into my main function. Okay, now I can say if version 1, version 1 is equals to 1. Here I say version 1, right? Print, print version 1 is what is used, or is used. Else if, that is, let me just use else directly. Else what is this? else print this. Okay, and I said that our what's it called, always end with end if, right? End if. Okay, it's same thing as our what, as our if condition, as our this if condition, if then our condition, you know, or even like our version 1. I say if version 1 is equals to 1, you know, print it is same thing, new line. Else print it is not same thing, it is print it is same thing too, or print they work the same way. But our, what's it called, our if obviously, you know, this one I have to what define, I have to define this version inside here to use my if statement, you know. Let me just declare its version. Okay, now look at it. If version is equals to 1, and here my version is 1. Oh, sorry, because I was wondering why should I have to declare it, because it should be the same thing. Aha, now it's working fine. Control flow. Okay, now this one is what? Conditional preprocessor. Okay, now look at it. If version is equals to 1, you know, here we have parentheses, but here there's no parentheses because it is a conditional preprocessor, but here it is a control flow. Now I said if version is equals to 1, then printf version 1 is used, else version 2 is, or else, let me just put no version. Okay, now obviously our version is 1. Okay, so definitely it's going to print out version 1 is used. Let's check it out. Look at it, version 1 is used. Then now the controller jump to this if condition, this control flow. That is, it is same thing. Okay, that is, they both work the same way, but this one is a preprocessor while this one is a control flow. Then the question will be like, when both are the same thing, why do we need it? It's because we need it when we want to, you know, if you are writing your header file and you want to, you know, input some things, then you will need this if this preprocessor directives condition. But you know, you can't use this if inside your main .h function, or any your .h extension function, your header file. That's why we need this preprocessor conditioner to check our, to perform. Okay, if this is not true here, then move to another thing. Okay, and again we can have else if. Okay, we can have else if. Okay, same thing as else if, but in preprocessor conditioner is called else if version 2. Okay, so that is, if this version 1 is not there, then I cannot have my my else block. Okay, my else block, that else block is just to print out, to print out the if none is true, if none is true, to print it out. Let me put a no version. Okay, now here let me say version 2 is used or is full. Okay, now let's change this one to version 2. That's what will happen. Look at it. Version 2 is full. Let me just take away this. We have confirmed that they work the same way. Okay, look at it now. Version, let me recompile. Look at it now. Version 2 is full. Let's assume that none is true. Let's put version 3 and let's check. Look at it. No version. Okay, now I explain something called undefined. It's undefined in preprocessor directives. Now if I want to undefine this version, okay, I cannot come here. I cannot come here in anywhere of my program and input like now undefined version. Okay, undefined version. So automatically when I say undefined version, I'm saying that this defined version rather, I want to undefine it. So none of these will be true. You see now, I can see. Let's try. Let's input 2. Let's input 2. As you can see, let's input 1. What's happening? Let's input 1. You see, I have no version, because I have undefined the version I defined here. That's why it's keep printing this else block. Now, if I want now define it back, okay, I can now go ahead and define it back. Define version 2. Look at it. There's now work fine. Version 2 is full. Please, do we understand? Do we